next speaker is not only an exceptional professional surfer and musician, but she also has spent an awful lot of time learning and working about science. Dr. Jessica Rose pursued her Bachelor of Science in Applied Mathematics at Memorial University in Newfoundland, Canada. Subsequently, a Master's in Medicine and Immunology. She was one of the 5 esteemed graduates of a newly established interdisciplinary degree program pursuing a master's degree in medicine with a focus on immunology. She continued with her studies in Israel, having been invited to pursue a PhD in computational biology, and successfully completed 2 postdoctoral degrees in molecular biology and biochemistry. Thank you so much for being with us, Dr. Rose, and please take the floor and enlighten this now huge, it seems that we have thousands of people watching online. Thank you very much.
Thanks for that intro. Wow, you found out about I was one of the first 5 in the interdisciplinary program. That's good stuff, good research. First of all, thanks for doing this, because I think this is probably one of the most important things that's happened in any of our lifetimes, this discovery. And there's going to be repetition in my presentation, but as has been pointed out, that helps learning. And of course, I have my own special way to present things. So if my slides are there, I can get started, and I am going to time myself. So of course, in classic Jessica style, I have to make people laugh. I hope this does. We penetrated your cabinet. Are you happy? So I hope that this makes some people laugh in the audience, because we really need it. So again, I'm going to go really fast here. I'm going to skip over some things that people have already talked about. The first thing I want to say here is Kevin brought up David Dean. Now, David Dean is like a gene therapist. He's the guy who's looking very closely at nuclear targeting of plasmids. He's the guy who's looking at, I'll get to this, but the best ways to get things to the nucleus. And he's quoted to have said, clearly, without the translocation of the plasmid DNA into the nucleus, no gene expression or gene therapy can take place. So what I'm saying here now is, since we have evidence that there is DNA in the modified mRNA COVID-19 injectable products, then these products, by any and all definitions, are gene therapies. And this is very important. Even if this wasn't the intended design, this is the result that we're facing right now. And this changed a lot of things. And that's why I'm really glad that Byron brought up the legal stuff, because basically what this means is that there was no possibility for informed consent. Where did the DNA contamination come from? So as was pointed out, there are 2 processes for manufacturing the modified mRNA. Process 1 was used, the modified mRNA was produced using PCR. Now, this was the product that was used in the clinical trials. Okay, there was like 20,000 odd people, and then some more that were injected following the unblinding of the placebo participants. Process 2 is the upscaling method. We had more than 40,000 or however many participants in the clinical trial to inject. We had billions, we had a whole world. So we needed a whole lot more product. So we need to upscale. The way that they did this was by moving this system, the mass production of the DNA, to make the modified mRNA in an E. coli system. So that's enter the plasmids in that step. But there are 2 concerns here. There's potential DNA contamination in the form of these DNA plasmids, and there's also lipopolysaccharide, which is this byproduct of using the E. coli system as a means to grow up all of this DNA. And it has been pointed out, at the end of this 5-step mRNA synthesis workflow, you're supposed to clean your product, your final product, your modified, in this case, mRNA, such that you only have that product that you send in a sack to get packaged in the fat bubbles. What happened, we think, we're pretty sure, is that the DNase, the enzyme that's supposed to chew up the DNA, didn't do its job. It's possible that there were hybrids of mRNA and DNA created, which made it very difficult for the DNase to function. In any case, it got left in there somehow, and It's also likely that lipopolysaccharide, which is the endotoxin, also got carried over. I think I better pick up the pace here. So the question becomes, can this contaminant DNA get to the nucleus of transfected cells? And I implore every single person to go read this article in ArcMedic's blog about 5 ways that this can actually happen. And it's all related to the product itself. The one I want to focus on is the SV40 enhancer. As has been pointed out, this is, before I do that, I'll get into all of this. I got an email from a reader. I get a lot of emails from people asking me questions, and it was, I want to put this here because I really think this reflects what a lot of people are thinking right now when they're introduced to what we're telling them. It's like, how would this happen? I don't understand. What would carry this DNA to the nucleus? And it's a very, very quick answer. It's the lipid nanoparticles. They've been referred twice now as Trojan horses, and that's exactly what they are. They are the little fat bubbles that package up this modified mRNA, which potentially has hybrids and all these other things for direct entry into the cells. It's like fast delivery. So what DNA are we talking about here? We've heard about the enhancer, we've heard about the promoter, we've heard about antibiotic resistance genes, and this is the part I want to stress, that the plasmid map on the right is the one that Kevin sequenced, one of the examples, which contains an additional antibiotic resistance gene, and the SV40 promoter enhancer here. So this plasmid map on the left, this cartoon, does not disclose these SV40 components. In fact, the promoter that they do disclose is a T7 promoter, which is commonly used in these systems. So the question becomes, why weren't these disclosed? And the reason why this is a really important question is because of what they can do, as you've all heard up to this point. SV40, simian virus 40 promoters, are very strong promoters. They're used in biotech for the purpose of the fact that they're very strong promoters. The enhancers are kind of the enhancers of the promoters. This is the reason why they're called enhancers. They are not necessary for transcription to ensue, but they make it really efficient. They amp it up. They make sure it's ongoing, for example. From my understanding, if an enhancer is present, it was put there with intention to optimize the transcription. So it's not enough that the promoter's there. Why is the enhancer there as well? So I'm of the opinion now that mistakes were not made with regard to this. If we reproduce this over and over and over again, and in my mind, there's no shadow of doubt now. There's DNA here. So I mentioned this SV40 enhancer before, and it was highlighted in terms of it being a nuclear location sequence, which means that basically it's like a FedEx vehicle bringing things to the nucleus. David Dean, that I quoted earlier, is also quoted to have said, "We have demonstrated the portions of the 72 base pair SV40 enhancer are required for the nuclear entry of plasmid DNA in all eukaryotic cells tested to date. Plasmids not containing the sequence remain in the cytoplasm until cell division, whereas plasmids containing the enhancer migrate to the nucleus within several hours." So this not only is a nuclear location sequence, it's very efficient, it happens really fast. And the problem with this has been mentioned are all of these things associated with, for example, insertional mutagenesis. It is one of the byproducts of this continued expression of the spike. We also have to be really concerned about transfection of stem cells and germlines, as Jancy was pointed out. So Philip Buchholz is an oncologist who's reproduced Kevin's work. And these are, this is a fragment size distribution plot that he created. So you can see here that there are lots of small pieces of DNA. And I heard Sukarit reiterate a feeling that I had, because I'm not a geneticist, I'm not an oncologist, but I figured that the smaller the bits of the DNA were, the higher the probability of integration. Philip has stated that it's based on the quantity of the DNA, but we have both of these problems here. We have a ton of DNA and we have small bits of DNA. And as Alexandra pointed out, this can lead to oncogenic activity. There's consequences of integrations to our genome, our DNA. There's a potential disruption of the tumor suppressor genes like the guardian of the genome, P53. There's potential for activation of dominant proto-oncogenes and dominant oncogenes. And I mean, at the very, very least, we have to grow a little bit concerned. And that moves me here because I'm running out of time. The VAERS reports of cancer, the leaves rustling in the wind, are shown here. And this is the reports per age group per 100,000 doses. So there are 21,000 reports now. This is not considering an underreporting factor, and 8.8% of these people have died. The top 10 listed cancers you can see here are on the left, and it starts with neoplasm, malignant neoplasm. But I'd just like to throw in here that a lot of rare cancers have been reported to VAERS as well, like acute lymphocytic leukemia in old people and breast cancers in males. This is a plot that demonstrates something that Mark said right at the beginning, whereby the shot number is actually going down. But if you look at the cancer reports normalized to 100,000 per 100,000 adverse events per year since the start of the COVID shots, it's on the uprise. This is probably the most worrisome thing that I've seen in VAERS on cancer so far. So this needs to be taken very seriously. On the subject of bacterial endotoxins, Kevin showed both of these papers. There are considerations for how we're measuring the endotoxin, and perhaps we need to lower the threshold. And on the far right here is an example where the endotoxin readout was actually redacted in a Spikevax document. So bottom line here is that maybe we need to lower the threshold, not only for the LPS detection or the endotoxin, but for the DNA as well. The potential physiological repercussions of LPS contamination include anaphylaxis, sepsis, toxic shock, and death. These are all pretty bad. Can't recover from death. The VAERS reports of anaphylaxis look like this. Most of the reports are being reported in 40 to 49-year-olds, but 1% of people have died. And when you add sepsis and toxic shock syndrome to the mix, the percent people that died goes up. You see a shift to the older age groups, which isn't surprising, and an increase in the number of people. The N is the absolute number of people in this group, and this is normalized data per 100,000 doses. And this is the last slide. I wonder if the percent RNA integrity, which we know is 18% lower in the commercial batches versus the clinical batches, isn't due to the arisal of DNA RNA hybrids. I have so much more to say about this in packaging, but I don't have time. So future work, of course, Kevin said this. We need to check plasmid, these components in stem cells and germline cells of real people. And we need to build up a data set of the sequenced files and correlate those to what we're seeing in pharmacovigilance databases. And that's it for me. I'm sorry I went over time by 2 minutes and 10 seconds. I'm a very bad presenter in that way. That's all for me.
Well, thank you so much, Jessica. As usual, a brilliant presentation. Yeah, so you're a very, very good presenter. Yeah, from the outside. Yeah, not only a good surfer but a good presenter. So, so thank you for very much, and I hope we'll come back to that later. Giving a round-up perspective on so many aspects. And one of the beauties of these panels, as we can see, is that so many different backgrounds add to another puzzle piece to the full picture. And we're now in an area of micro-specializations in science with dozens of subdivisions. And yeah, it's so rare that people actually come together from different disciplines to discuss a topic. And in other words, the specialization proceeds. People supposedly know more and more about less and less. So thank you very much for bringing all that together.